Hello,
What's your name?
my name is Skylar.
I'm William.
I'm Cameron.
And I'm trying to get this microphone off. There we go. Okay, so this drawing here was for the experiment that we did yesterday, which was on photolithography. And very briefly, photolithography is the process of using light to pattern materials and etch them out so you can create very, very small structures on the nanoscale for industrial purposes.
All right, so this artist drew I think that is a wooden block, and I'm shaky, wow. And that is a paintbrush painting like a coating, and in the next arrow over, we see fire, and it is only burning the part that is not that does not have a coating, and in the next arrow, the same thing is happening, and we can see that it's making a staircase, and we see that the staircase is very large in scale because the height of one step is about the height of one person, so that is way too big for a staircase. And so, but here they are making the paintbrush thinner by cutting it with a knife, and so if you make the paintbrush thinner, then the coating layer is also thinner, making the fire able to make a staircase that is able for the humans to actually walk on, that is like not so tall as the original. And there is a comparison of a dirty environment and a clean environment. And so in the dirty environment, it says that this person is getting stuck, but in the clean environment, they can walk up. That is, yeah. Okay.
Awesome. So photolithography itself, it's about a 6-step process, and basically what you start off is a 3-layer wafer. It has a substrate on the bottom, which basically is just sort of like a base. It just holds it together. And then the next layer in our experiment was a layer of copper, and then the layer of that after that was a layer of photoresist. So photoresist is a chemical that changes its properties when interacted with light. So our photoresist, if you shine light on it, it would actually dissolve and turn into a liquid, and then you could remove that liquid later. So the first step of photolithography is to coat it in photoresist. So for us, that was already done. And then the second step is to put on a mask, which is sort of like a pattern. And the mask is just certain black lines and dots, and then certain negative space. And so light can shine through the parts that aren't covered by the mask, and it shines through to the photoresist, which basically dissolves the photoresist, leaving under it a pattern that was like sort of made by the mask. And so after that, the next step is to develop the photoresist. So you dip the whole thing into a chemical, and it washes away all of the photoresist that was dissolved by the light. And then after that, you etch the whole thing. And so the whole point of putting the photoresist on was to have certain parts be protected from the etching. And so the etching material goes into the copper that's left behind by some of the dissolved photoresist. And you etch the parts that you want to etch out of the copper. And then so that's the etching step, and then the step after that is just to finally strip away the top photoresist, and what you're left with is the whole etching of copper that you wanted from the beginning. And this is used mostly when you're trying to make computer chips, so like for Intel or something like that, they have to make very, very tiny wires, processors, resistors, and photolithography is how they're able to do that. So with this metaphor here, it sort of goes into 4 steps here, so that's one of the limitations we'll get into in a moment. But putting the paint on is equivalent to putting on the mask. It basically prevents putting on the mask and the photoresist. It's what prevents the rest of it from being etched. So as you can see, the fire is like etching all the way down through the copper, through the material. So putting on this little paint protector thing kind of protects that specific spot from the dissolving. And then it sort of works its way down all of the stairs. So the fire burns down a little bit on one step and then next, and that's how it gets its structure there. And then, so the fire is like the etching. The fire is what burns through the wood, and the etching is what sort of burns through the copper and gets dissolved away. And so the other concept here is that you can have different sizes of nanostructures. So here we have the large structure that's sort of too big and not very functional because you can't climb steps that are 6 feet tall. And then here we have the nanostructure that's much smaller, and it was made by smaller tools. So what's important is being able to use smaller tools to be able to get the exact size of structure you want, which is usually very small. And in real life, ways you can do this are using electrons potentially instead of actual light, because light is limited by its wavelength, which is still really small, but because we're on the nanoscale, it's not quite small enough, and it's still really big. So it's important to be able to get very fine resolution there. And then the last concept, there's a lot of concepts here. The last concept is the clean room. So if you've ever seen one of those factories where they're making processors, the clean room, the scientists are wearing bunny suits, and it's very sterile. There aren't any particles. And that's because if you have dust on the nano chip, then it sort of messes up all the circuits and it makes it unusable. So here, the dust and muck makes the stairs unusable, and the clean is much better.
All right. So this is the good, the bad, and the interesting of this metaphor. All right. So to start off, what we liked was that the paintbrush metaphor, it was very easy to tell that the scale size, when the scale size is changed, it's easy to switch from 10 feet to 2 feet, and it's much easier, and that directly relates to the stuff we used in class with photolithography, except it's not on the same scale. It's not from 10 to 2. It's much larger scale of difference. And another thing we liked was that this person was a very talented artist, and that it's very easy to tell what's going on. Unlike us three, we're not very good at that stuff. So, and also the clean room is very easy to tell, as the person's stepping on gum as he's going up, and the next stair is very clean. And so some things that we thought could be improved, although photolithography is a very complex process, which is very hard to capture in one analogy. So this had 4 steps actually, but the actual process has 6 steps, which is one of them is spinning, which is not included in it, and developing. But that's okay because, I think us three easily got what the process was, but, and like I said before, it's very hard to get all of those steps into one easy analogy. And one other thing that we didn't understand was the paintbrush, what it's actually painting. We weren't too sure if it's wood or it's like fire retardant, which is how they got the steps. But other than that, we thought the drawing was very unique and artistically pleasing. But with a few improvements with labeling and some more steps, then it would be very clear and concise. Thank you.
Okay, I would just again say, try to talk about it as the limits of the analogy. So you guys just talked about it, but I ask you again to say slightly different. So this analogy captured some of the essence of the photolithography process, but it left out some, not the mechanics like spinning, but it left out some of the essence of the photolithography process because that's just, this analogy cannot capture them. So what are the things that this analogy did not choose to capture?
So this analogy, it didn't capture the development phase. In actual photolithography, when the photoresist is exposed to light, it turns to liquid, but it's still it's still part of the structure, so you have to find a way to wash it away. And in our experiment, we put it in developing fluid, but that's not seen here. In fact, I think if the paint is the photoresist, then it's never washed away altogether, and instead we get the etching, but we never get the development phase.
Okay, so that would be one, the removal of the pattern making component. So there's another big concept in photolithography that is not tried to be in part of this?
Is it the mask?
What's the name?
The mask of...
No. What's the name of the process? What?
The entire experiment.
Experiment is called?
Photolithography. So the photo.
The photo. So, how could you possibly incorporate that if you wanted to? Let somebody else.
We could have a blueprint of what the structure is supposed to be like, just like we have with the photoresist. Before doing it, you have what it's supposed to be, and you transfer the material.
Yeah. Some kind of pattern transfer is sort of the idea. This has all the lithography, but this analogy is not trying to have the photo pattern transfer, and that's okay. You cannot capture all of it, but so those are the kind of things to say. What are the limits of this analogy? What are they not trying to capture, but is part of the real experiment? Okay, questions from the audience?
So one of the other big concepts that the lab talks about is when you guys made a thick wire versus a thin wire. So can you talk about that part of the experiment and what you learned from it? And then is there a way that that can be put into this analogy?
Okay, so so in the actual experiment, the thin wires had more resistance because sort of like how a smaller pipe has more resistance to water flow. It's harder to put as much water through. The thin wire has a harder time putting through a lot of current. So the thin wires have more resistance, whereas the thick wires have less resistant and can do more current. And to be honest, I know there are a bunch of extra concepts that the artist could have chosen to do, and I kind of feel like putting the different sizes of the wire in some kind of metaphor would be a little outside of the scope of the metaphor of stairs.
So what if the stair steps were really, really small? What if the increments were barely visible? Then what would it be instead of a staircase?
Like a ramp?
So what if the ramp were really steep?
Then it would be sort of like the stairs that are really steep, and it would be mostly unclimbable and unusable.
And then it'd have more resistance to people going up. Yeah.
They'd have more resistance. Or they could have been skinny stairs and a whole pile of people in a line trying to get up. You've all been stuck at an escalator that's too skinny and nobody can get up. So those are just ways to think about where you could put in extra concepts. Okay, questions from the audience. We need a parent question. Yay.
Did you use different wavelengths, and how about the time, the exposure time?
Okay, so exposure time is, it's not really something you want to change, because if you overexpose, then you sort of just go too far, and then it just sort of ruins it. And if you underexpose, then you can't quite get the pattern you want. So exposure is just a very specific time that I think they just figured out through trial and error, to be honest. And then different wavelengths of light is portrayed here with the different sizes of paintbrush. So a smaller wavelength of light or a smaller paintbrush can get finer resolution on the stairs. It can get the smaller steps that have better function.
Okay, any more questions? All right, good job for this team. And